All right. Good day, everyone. My name is Christopher Akpogome. You are welcome to the Chemistry Mastery Academy. Today, we are going to be looking at the topic chemical combinations and bonding. Chemical combinations and bonding. Now, basically, what we are going to be looking at today is how do the reactants combine. Remember, in the last class, we looked at what do you call it now? Balancing, writing and balancing chemical equation, right? And so now today we're going to look at chemical combination and bonding. So when you bring different reactants and then you mix them together, how do they mix? That's what we're basically going to be looking at. Now, the way and manner in which they mix is actually dependent on the characteristics of each of those words elements that you are mixing, or each of the reactants you are mixing. Now, for example, now in chemical combination and bonding, we have two types of bonding. We have what we call electrovalent bonding, and we have what we call covalent what bonding. Now, electrovalent bonding, which is also known as what ionic what bonding. Okay. Now, what does it entail? Now, electrovalent bonding involve an element that is transferring electrons from its atomos share. An element that is transferring electrons from its atomos share to another element. Okay, so in electrovalent bonding, you have one element taking electrons from the last share and sending it to the last share of another what element. Now, that element that is transferring its electrons to another element, that element that is doing the transfer of those electrons is called a metal. So in chemistry, we will define metal as a what? A substance that transfers its valence electrons to another what? Element. Now, when we say valence electrons, we are talking about the electrons in the atomos share of the what? Element. So valence electrons are the electrons in the last share of that what? Element. We are going to do some illustration, but I just want you to get a foundation about this electrovalent what? Bond. Electrovalent or ionic what? Bond. Now, we have said that the element that is transferring valence electrons, or that is transferring electrons from its atomos share, is called a metal. Now, when it transfers that electron, okay, when it transfers those electrons to another element, it now becomes an ion. And in ions, we have two types of ions. We have cations and we have anions. Now, cations are those ones that have positive charge, while anions are those ones that have negative charge. Now, what determines whether the element will have a positive charge and what determines whether an element will have a negative charge is simple. When an element is transferring electrons to another element, that element that is transferring electrons becomes positively charged, while the element that is receiving the electrons becomes negatively charged. So, the one that is positively charged, which transfers electrons, is called a cation, while the one that is negatively charged, which receives the electrons, is called the what? Anion. Therefore, in electrovalent bonding, the element that does transfer of electron can be called a metal, it can be called a cation. Are we following? Okay. Now let's look at some illustration as pertaining to electrovalent or ionic bond. Okay. I hope you can see the board. All right. So we have, let's use an example of sodium. Now, sodium, which has the symbol Na, has how many electrons? It has 11 electrons. It has how many electrons? 11 electrons. Now, let's draw the shares. Okay? Now, if it is 11 electrons, that means it is 2, 8, 1. Why is it that? Now, this is the first share, this is the second share, this is the third share. Now, you notice that the first share has 2 electrons. The second share has 8. Now, why is it like that? It's like that because the first share of any element, the highest number of electrons it can carry is 2. Okay? So once that first share has the 2 maximum number of electrons, any other electron that is remaining to be represented in the share will go to the what? Next share. So let's draw the share. We have the first share, 2 electrons. Then we have the second share. The second share has 8 electrons. 1, 2, 3, 4, 5, 6, 7, 8. Did you see the way I arranged it? This way, the way I was arranging it. That's how you arrange it. So you don't put 2, 4, 6, 8. No. You put 1, 2, 3, 4. Is many 4, Abi? 5, 6, 7, 8. Exactly. Then the last share has how many electrons? 1. This is sodium. Now, this sodium that we have here can easily give out this valence electron. That is the electron in the atomos what share, the electron in the last share. It can easily give it out. Exactly. So the next question you now ask yourself is, what actually determines whether the bonding will be electrovalent or covalent? Now, what determines whether the bonding will be electrovalent is dependent on the willingness of that element to give out its electron or to what? Receive electrons. Now, in this sodium, the first share can carry only the highest number of 2. The second share and other subsequent share can carry highest number of 8, right? Now, this sodium that is here is not stable. Why? Because this is last share is carrying 1 electron, whereas it's supposed to carry what? 8. Are we following? Remember we said that the normal, the maximum is supposed to carry is 8. But now it's carrying what? 1. So it needs 7 to complete it, right? But it will be easier for it to give out this 1 and lose this share so that it has this share that has 8 electrons. It will be easier for it than for it to say it wants to collect 7. So there is more work involved when it wants to collect 7, because if it wants to collect 7, it will have to go to different what? Elements that will be willing to give it the 7 to complete it. But now it will be easier for it to just release the 1 and then attain what is octet what? Structure. Octet structure, that is a structure that the maximum number of electrons in the atomos share is 8. So once it gives out this 1 now, the maximum number in the atomos share, this will not be the new atomos share. This one, so this second one, number 2, will not be the new atomos share. So the maximum number is 8, so octets. Now, we have duplex structure. Duplex structure is when the element has only 1 share, and that 1 share has 2 electrons in it, which is the maximum number. So that one we say is a duplet what? Structure, stable duplet what? Structure. Now, so this sodium is a metal because it finds it easier to give is 1, transfer is 1. Okay, so this is sodium is a metal. Now, it means that sodium will undergo what we call electrovalent what? Bonding, because sodium gives out its valence electron willingly and easily. Are we following now? So it means that an element that gives out its valence electrons easily and willingly will undergo electrovalent what? Bonding. And an element that will easily collect easily collects the electron that is being given to it, that it will willingly and easily collect the electron that is being given to it, will undergo electrovalent bonding. So now we have sodium giving 1. So which element can sodium give 1 to? So that when it gives that 1 to that element will now be balanced, while sodium will also be balanced. A typical example is chlorine. Now, chlorine with the symbol Cl has 17 electrons. So we have 2, 8, 7. Automatically, you can see that if this one, sodium give this is 1 here to this one, this 7 will now be 8. Okay? And then we remember that we said that the maximum number of electrons in the atmosphere is 8, right? So this chlorine is now balanced. Then this one is now off from this place. This one will now be added to this 7 to make it what? 8. So you see that 2, 8. The atmosphere has what? 8 electrons. Is balanced. 2, 8, 8. Atmosphere has what? 8 electrons. Is balanced. Let's draw out the what? Structure now. So let me put this one here back and put this 7 here. So we have first share has 2, second share 1, 2, 3, 4, 5, 6, 7, 8. Then third share 7, 1, 2, 3, 4, 5, 6, 7. 7. Now, electrovalent bonding can take place between these two. Why? Because sodium can easily give out this one that it has here. And chlorine, which is here, can easily collect the one. Remember, how many does chlorine need? Only 1 to balance it to make it 8. And then sodium has that 1 to give to what? Chlorine. Is that clear? So these two undergo what we call electrovalent what? Bonding. So this will now come here. Automatically, you will now have this, this, this. Then we have this, this, this. 2, these 2, 2, 4, 6, 8. Then this one that is here has joined to this one. This one that is here is here. Then this 2, then this 2, then this 2, then this 8. Now this has formed, we take the first Na symbol Cl. So this is how sodium chloride is what? Formed. You know, sodium chloride is a salt. This is how it's formed. Exactly. So what we have here is an electrovalent what? Combination, or electrovalent what? Bonding. And what is the bond here? We have what we call electrovalent bond or ionic what? Bond. I believe that's clear. Alright, having said that, let's now move on to the other type of bond, which we call. But before we move on to the other type of bond, let's look at some properties of ionic what? Compounds. Now, in ionic compound, first of all, let's understand what ionic or electrovalent compounds are. Excuse me. Now, electrovalent or ionic compounds are compounds that are formed when one element transfer its valence electron to another element that willingly what? Collects it. So that one that transfers is called the electron donor, while the one that collects it is called the electron acceptor. So when two of them join together, they form what we call electrovalent or ionic what? Compound. Now these compounds, they are solids at room temperature. Sodium chloride, like we looked at, is a salt which we use to cook, right? Now, in the room, is it not solid? It's solid. Then we have number 2 property. It has high melting and boiling points. And then number 3, it conducts what? Electricity when it is in a molten or dissolved what? Form. That means if I take that salt that we used to cook, I put it in what? Water. And it dissolves. Then I take, what do you call it? What do you put it now? I take a copper wire or so that has current, and I put it into that what? Dissolved what? That liquid that has dissolved salt. What will happen? Electricity can move into that dissolved what liquid, that dissolved salt, and move from there. If peradventure I connected it to another device, can move from there and what? Into that other device. That's why we say it can conduct what? Electricity when it is in a molten or dissolved form. Then another property of ionic compound is that it dissolves in polar solvent. Polar solvent. It dissolves in polar solvent. Example, water. Like your salt now, it can dissolve in what? Water, is it not so? So, ionic compounds, any compound that you have an element transferring its electrons to another element, dissolves in what? Polar what? Solvents. Example, water. Now, having said that, let's move over to covalent what? Bond. Covalent bond. Now, in covalent bond, we don't have transfer of electron from one element to another. Rather, in covalent bond, we have what we call sharing of what? Electrons. Sharing of what? Electrons. Now, it's either one of the elements brings the electrons that both of them will share, or both elements brings the electrons that both of them will what? Will share. Are we following it now? So in one case, one element is the one bringing the electrons. Well, that electron that is bringing is not sending it completely to the other element. No, both of them will be sharing it. Or another case, this one will bring his own, this one will bring his own, and both of them will share it between themselves so that they can what? Be balanced. The whole essence of this combination is to attain a balanced state. That's the whole essence of this combination, is to attain a what? Balanced state. Okay, so now in covalent bond, we say we have two scenarios, right? So we have ordinary covalent bond and we have coordinate covalent bond. In ordinary covalent bond, one element brings the electron that both elements shares. Both elements share. While in coordinate covalent bond, this element will bring, this element will bring, and those elements that each of them bring, both of them will share it. Are we following? All right. Now, let's look at properties of covalent compounds. Of course, we know that when we say covalent compound, we are talking about those compounds that are formed when you have different elements in which one is either bringing for both of them to share, or both of them are bringing for both of them to share. So that's a covalent compound. Now, what are the properties? Now, covalent compounds are what? Gases or soluble liquids. They are what? Sorry, did I say soluble or volatile what? Liquids. They are gases or volatile what? Liquids. They are gases or volatile liquids. A typical example of covalent compound is what? Hydrocarbon. And specifically, what do you call it? Is it fuel now or petrol? Or premium motors or spirit, PMS. So you are used to what? Fuel, right? Good. The one that you put in your car. That one is a typical example of what? A covalent compound. Now, have you noticed that when you take fuel, let's say fuel pours on your hand, it feels cold, right? It feels cold. Then before you know it, the thing will just disappear. And yet, it's a liquid, but it's not your normal liquid. It's what we call a volatile what? Liquid. It behaves like a gas, but it's not a gas. So we call it a volatile what? Liquid. That's why when it pours on a surface, it doesn't take time before it what? Evaporates. It evaporates what? Quickly. Are we following? So hydrocarbons are a typical example of what? Covalent what? Compounds. Then another characteristic of covalent compound is that they have what? Low melting and boiling point. The another thing is that they do not conduct what? Electricity. Another thing is that they dissolve in non-polar solvent. They don't dissolve in polar solvent. If you take petrol now, pour it in water, there's no way the petrol and the water will mix. It will not mix. You will see the petrol either floating on the surface. Okay? So that's why we said it dissolves in non-polar solvent. It does not dissolve in polar solvent. I hope that's clear. All right. So I'll see you in our next class. So do well to subscribe to our channel so that you can get more videos, more lectures, and get better understanding of the